Okay, we go to the sane demented problem, and we can indicate that just by saying we got 400 sane, 600 demented. We got an arrow 10% going from here to here, meaning that 10% of our sane become demented, and that 600 of our 20% of our demented become sane, indicated by the 20% arrow going here. Now, what do we have after the first transition? Well, we have 400, we have 600 to start with. We have 0.1 times 400, which is 40. That's the 10% of the sane that go over to the demented side. And 600 times 0.2, that's 20% of 600. That's 120 coming back to this side. So what do we have? We have 40 sane being lost, 120 being gained. That's a gain of 80, giving us 480. And I write that as 400 minus the 40 that goes over this way, plus the 120 that comes back this way. Just the most straightforward way of depicting what actually happens here. And then for the number of demented, we're going to have the 600 we started with minus the 120 that come across here, the 20%, plus the 10% of the sane that come over, the 40 sane, and that gives us our 520. And we still have 1,000 people. We have 400, 600, that makes 1,000, 480, 520, still makes 1,000. Now what I want to do is I want to symbolize this. So if S and D stand for the number of sane and the number of demented, then how am I going to depict? Well, okay, if S is the number of sane, you want to think about this. If S is the number of sane, then according to this rule, how would you represent the number that go over to the demented? And if D is the number of demented, how do you represent the number that come over to the sane side in terms of S and D? Well, hopefully you've thought about that, and hopefully you got this, that the number of sane that go over to demented is, well, 10% of the sane go to demented. 10% of the number of sane, S stands for the number of sane, so 0.1 times S stands for the number of sane that go over to the demented. And 20% of the demented become sane, and that's going to be 0.2 times D come over here. Now, how are we going to write expressions that correspond to these? The actual calculation of the number of sane and the number of demented we're going to have after a transition. Think that through in terms of the symbols S and D. Okay, well, hopefully you've thought it through, but it's going to be, well, we start with S. 0.1 S goes over here, so we're going to lose 0.1 S on this side, on the sane side, and we're going to gain 0.2 D. So it's going to be S minus 0.1 times S plus 0.2 times D. On the other side, we're going to have the D minus the 0.2 times D plus the 0.1 times S. Now, I ask, and I'm kind of covering it up so you don't see it, hopefully you haven't looked at it, but how can we simplify this expression? If this expression occurred on a test in Algebra 1, you would be able to simplify it, I hope. So how can we simplify it? Well, people had a little trouble with that question. They didn't see what to do to simplify it. So I asked this, okay, over here on these first two terms, D minus 0.2D, is there anything I can factor out? Again, you ought to stop and think about that. But the answer is, hopefully you've stopped, but the answer is that, yeah, we can factor D out of these two. So what do you get if you factor D out of D minus 0.2D? Okay, well, you get D times 1 minus 0.2. And you should understand that. Factoring, in this case, just being the reverse of the distributive law, D times 1 gives us D. D times negative 0.2 gives us minus 0.2D. And we're still going to have our 0.1 S. Now, can you simplify this? How do you simplify D times 1 minus 0.2? Well, hopefully you see that right away. You don't have to think about it. 1 minus 0.2 is 0.8, right? So that's 0.8D plus 0.1 times S. So of course d minus 0.2d means 1d minus 0.2d. That means 0.8d, but seeing this factoring step here helps you be sure that you're doing that correctly. And the same thing can be done over here. S minus 0.1s. We could factor the s out. We get s times 1 minus 0.1. 1 minus 0.1 is 0.9. So one way or another, we see we got 0.9s plus 0.2d. Okay, so that's how we can write in terms of symbols what happens in any transition. If we know the number of sane and the number of demented, we've really got something kind of like a formula for the number of sane, 0.9s plus 0.2d, and the number of demented. It's going to be 0.8d plus 0.1s. These numbers for after the transition, if these are the numbers before the transition. Okay, well, that's very good. And we can summarize that by saying S becomes 0.9s plus 0.2d. D becomes 0.1s plus 0.8d. Well, in a minute, I'm going to do something that anticipates the whole concept of matrices and the use of matrices. Something that's been unaccountably, I can't imagine why, left out of Algebra 2. It's probably left out to include something else, but matrices are so fundamental, I have a little trouble grasping that. Okay, well, anyhow, we're going to stop here, and then we'll pick up the rest of this on the next video.